the lead back. That was already in my
This is the beginning of the video. I'm going to crop this out. So get all of your giggles, all of your craziness, all of your wildness out for Kayla.
1 minute. Not me, I was just saying.
Did Sydney seriously just leave?
Yeah.
But like why? Like does she have doctor's appointment or?
She might just not. I don't know. Okay.
She's so probably.
She didn't even know.
Wait,
she
what
was
colors we doing?
I don't know. Okay.
Let me look through my bag of colors.
I do have to sit like over here, so I'm sorry for that, but I have to be close to like the recorder.
That's so rude. Anyway, sorry. Can we do a lime green and a green?
I heard lime green and what else? And I was blowing my
Dark
nose.
green.
And a dark green.
Some green.
Green is my favorite color.
That's my last name. So basically,
Really, I couldn't tell by your sweater and your phone case.
Or by my bridesmaids
Or your
colors.
bridesmaids colors. Or your
Oh,
sister's
green is
green.
Yeah, that's also green.
Green.
green, that's
Well,
green. You can tell my like in drawers are also green because that's my favorite color. And
that's
then like
your favorite class.
no, this is all of my classes.
Oh.
This is in, this is out, this is notes, and this is
What
copies.
is in and out?
Like
A
to be
restaurant?
graded, to be handed back out.
Oh.
And then now it's also
So like stuff that I know is already done, and then the notes are like and then copies are like tests, quizzes, handouts, all that fun stuff.
crap. Actually, before
Notes
we
are like
start-
your packets, and then the bottom is just miscellaneous.
Bless you.
That's a fun word.
What is that word?
Okay,
It's
this
just
green,
random.
Yeah.
this green,
Yeah,
this
that's
green's good. Okay, and then like a light green, you said
Lime.
lime, neon green.
No,
Oh.
that's a little too much.
Is that fine?
Yeah.
Okay. Alrighty. Oh, look, I already forgot a T.
You.
Oh, what?
Wait, what do you mean I forgot a T?
It says 4 pars,
Four.
Oh, yeah.
What?
parts.
Right
Oh,
under
four parts.
Pythagoras.
Oh.
Sorry about that. Alrighty. So we have talked about the Pythagorean theorem before. So today we're just going to kind of delve more into it, and we're going to talk about some of its other properties because it has some other ones. And there are 4 parts of a right triangle. So the first part we should know, of course, is the right angle. Right, if there's not a right angle, it's not going to be a right triangle. Okay, and we see that in this image. That's this part right here. And then it's going to have, what do the angles in a triangle add to? 180. So if I have like 2 angles, so in this case, like the measure of angle A plus the measure of angle B plus 90, that's going to equal what? 180. And so then I could subtract 90, right? So that means the measure of angle A and the measure of angle B is, guys, 180 minus 90. 90. Good Lord. Okay. What does it mean if 2 angles add to 90 degrees? Do we remember what that's called? It does start with a C.
Is it CR?
No.
CO.
Yes. Complementary.
Yeah, I literally helped y'all.
Right? Supplementary is what it means to add to 180. Complementary means they add to 90. Okay? It also has 2 legs, which again we talked about last class, which are the little parts on the side. So that would be, B and A in this scenario. And then we have what's called the hypotenuse. Oh, man. I have a hippopotenuse sweater, and I didn't wear it. I'm very upset at that. It's my favorite sweater. Okay. So the Pythagorean theorem can be used to find the length of any side of a right triangle given the other sides. Again, we have done this to some degree before. So we're just going to do it a little bit more today. But this time, before we were doing it with like decimals and stuff, or not we were doing it with decimals. This time we're going to do it with radicals. Does that make sense to everybody? Yeah. Okay, can somebody close my door for me?
I got you.
All right, so am I trying to find the hypotenuse or a leg here? I'm trying to find the hypotenuse, right, because it's across from the right angle. And so what would I call that, A, B, or C? C. And again, we remember that this is A squared plus B squared equals C squared, right? That is the Pythagorean theorem. Does that make sense? Okay, so does it matter which one I call A and B? Between 16 and 15? No, I'm going to call this A and this B. It really doesn't matter. You could switch it. That's fine. So what am I going to do?
6 squared plus 15 squared equals x squared.
Equals x squared. Very good, right? So let's think about our perfect squares. What is 6 squared? That one we should know. 36. Do you know what 15 squared is? 225, because we used a calculator. Okay, and that equals x squared. So we'll add those two together. And we'll get, what, 261?
Yeah.
Okay. So now we want to see if we can simplify it. So it obviously doesn't divide by like 2, so it won't be 4. How could I tell if it divides by 9 or not?
If it adds
Yeah.
up, and it does.
It does. So is this divisible by 9?
Yes.
Yeah. Okay, so 261 divided by 9 would be 9 and 29. Does 29 split up at all? No. It's a prime number, so it's actually going to kind of stop there. Equals x. So how could I rewrite that? What's the square root of 9? 3. And then can I take the square root of 29? No. So it's 3 root 29. Okay.
I keep forgetting that one rule. Like if it adds up to 9, then it's divisible by 9. I keep forgetting.
Or if it adds up to something that's divisible by 9, so like if it adds up to 18, that's divisible by 9. Okay? Or like if you have like 1, 2, 3, 4, 5, 9, 7. If you add all that up and it's still too big of a number for you to figure it out, you can add that number up too.
Just kind of.
Yeah. Until you get something where you know it's divisible by 9. It also works for 3. It doesn't work for every number though. Only 9 and 3.
Of course.
Work for 6.
It does not work for 6. Now if it's divisible by 3 and then divisible by 2, then that would work, but 9 and 3 only. Okay, so the next one, am I trying to find a leg or am I trying to find the hypotenuse? A leg. So in this case, what would like C be? 30. And that one, we have to know that one because we have to know it's across from the right angle. We can't just say like, oh, any side can be C. That one's special. But between A and B, we can switch them out. So which one do you want to call A? Okay, and then this we can consider B, but I'm still going to use X in that scenario. So I'm going to do 24 squared plus what? I'm going to call it X squared equals 30 squared. Okay. 24 squared, 576, plus X squared. You could maybe do this. What's 3 squared? Yeah, so 3 squared is 9, and then 10 squared is 100, so that's why it's 900. Okay. So then what do I need to do? Subtract 576. So what is it, 324?
Yeah.
Okay. And then let us try to take the square root of that. Okay. So that one's not divisible by 9, right? Because oh, yes, it is. I'm sorry. Yeah, you're right. I'm sorry. I got ahead of myself. So what's 324 divided by 9? 9 and 36. Ooh, what's special about both of those? They're both perfect squares. What's the square root of 9? 3. What's the square root of 36? 6. 3 times 6 is? 18. So we don't have a radical in our answer, and that's okay. This is technically still simplest radical form. Does that make sense? All right. Why don't you try C on your own? Because we're going to do D together. I can pause. You want me to pause it? I'm just going to leave it go, and then I'm going to cut it out. But then it's going to be too small for me to cut. No, I'm just going to leave it going. You guys are doing so well. I'm going to do it in the dark green.
Okay. I'm scared.
It's just because Sydney's not here, so I haven't been to talk to you. But C, 25 is C. Yeah. Here it is. Very foreboding footsteps. You sound like my mom right now.
Does your mom wear heels every day?
Every day.
That's commitment. I do it sometimes.
Every day, and then she stands all day. She's a principal, but like she has like a desk like that, and she lifts it up and stands all day.
Is she one of the ones that like jingles your keys as she walks? All principals do that, or like even assistant principals.
Oh, it's 4:30. I'm trying to do it. I have to do this.
Are you guys staring at it and you're like, what is it?
We're trying to, yeah.
It's 4.
It is?
Yes.
No, it's not.
It's not.
Because that's 35.25. Is it?
Maybe I got the wrong number. I don't know.
Mm-mm.
Oh. What?
There's not.
So that's it? Oh.
Yep.
Okay.
All right. Are we good? Can I go? Okay. Start the video here, future me. Okay. So we're going to do, again, we can call either one of these A and B. It doesn't matter. But this one has to be C. So we're going to do 25. I'm sorry, not, yeah, 25. I don't want to write it like that. 22 squared plus x squared equals 25 squared. What is 22 squared? 44 plus x squared equals 625. So then we'll subtract 484. So we'll get that x squared equals 141. Okay, and so then we would take the square root. So maybe you look at 141 and you're like, okay, all of those add to 6, so it's going to be divisible by 3, right? Okay, do we understand that? Okay, but it's not divisible by 9 because it doesn't add to something that's divisible by 9.
So if it adds to 6, then it's 3.
Yeah, because 6 is divisible by 3.
Okay.
Okay, so it is divisible by 3, but when we divide it by 3, we're going to get 3 times 47. Are either of those perfect squares or can split up further? No. So really our answer, the simplest perfect square, is the square root of 141. Because neither of those are perfect squares, and 47 doesn't split into anything that's going to be a perfect square. It doesn't help us at all. Does that make sense? Okay. So what about the next one? What's the problem with the next one? There's 2 missing. So if right now I tried to set this up, it would be x squared plus y squared equals 12 squared. Can I do that? No. But what I can do is use the stuff that we learned last class.
Yeah, part.
Okay. So which one do we want to do, x or y? X. Okay. So this is a leg. So who remembers how I would set that up? What goes first when we're working with a leg?
Not the part, right?
The hypotenuse. What's the whole thing? 12. So it's going to be 12 over x equals x over 9, right? Hypotenuse over leg equals leg over part. Does that make sense? Okay. So then we're going to cross multiply. So 12 times 9 is what? 108. And we're going to get that that's equal to x squared.
Why can't you do
Because we're missing 2 legs here.
it's divisible by 9? So
We're not, like,
wait.
before we were only missing 1 leg. Do you see that? Here, if we tried to set it up as is, it would be x squared. Oh, actually, I lied to you. I'm going to change this.
X as C and then 9 is
X squared.
Can you actually erase all this?
What?
I changed my mind. You can, so you can do it the way that we just did it. But the other thing that we can do is, do you see how this is technically a right triangle right here?
Yeah.
So can I do the same thing with that? Yeah? Okay. So how would I set that up?
X is C.
X is C, so it'd be 9 squared equals x squared. Very good. Does that make sense?
Yeah.
Okay. So what's 9 squared? 81. And 5 squared is?
25.
So equals x squared. So that's going to be what? 6. Yeah. And then we'll take the square root. Okay. So what do we think? We know it's divisible by 2, but is it divisible by 4? No. So it would be like 2 times 53. Is 53 divisible by anything? Not really. So really, can this split up at all? No.
So it wouldn't work the other way.
Square root.
Yeah.
It wouldn't work the other way that you did too.
It should. I think the problem's wrong.
So square root of 106 and 3 square root of 12 is
They're not the same. I think the question is wrong.
okay.
Yeah.
Now,
If
this
you
is
did
fine.
it that way on a test, I would take it though.
Okay.
Yeah.
Is the homework gonna be like that?
No,
You want us to
It'll
do
be
A squared
it'll
plus
be
B
right. I would like you to do a squared plus b squared equals c squared, but it'll be right either way on the homework. Okay. All right. What about for y? How would I set that up?
Why C?
Y is c.
I know. I have to know. I have to get out, but I said
Yeah. So we do 5 squared plus 3 squared equals y squared. So what is 5 squared? 25. And what is 3 squared? Okay. And so that's going to be y squared. 25 plus 9 is 34. Yeah. The question is wrong. I just checked. It is. So then we'd square root, right? Okay.
It's not
34 is not divisible by 4. It's divisible by 2, right? But when we divide it by 2, it's 2 and 17. Are either of those perfect squares? No. So it would stay as the square root of 34 as well. Okay. Does that make sense? Sorry. You can also do it on the other way. On a test or a quiz, I would take it each way if I didn't state, like, use the Pythagorean theorem. Okay?
triple.
Yes. All right. So there is also something called a Pythagorean triple, which is why the last question is technically speaking wrong. But there's also this thing called the Pythagorean theorem triple, and this is a set of positive integers. What's an integer?
All positive and negative numbers.
And so this is just the positive one. So really it's like the whole numbers, right? Well, actually it's the natural numbers. I lied to you because it doesn't contain 0. It's natural numbers that fits the rule.
Zero not natural.
Because whole numbers are 0 and all the positives. Natural is just all the positives. So really this is talking about natural numbers. Okay? Let's take a trip back to Algebra 1 for a sec. Can I go? So we have 4 sets that I really am going to require that you know. And that is the triple 3, 4, and 5. The triple 5, 12, and 13. The triple 8, 15, and 17. And the triple 7, 24, and 25. So these are Pythagorean triples. That means if you see 2 legs that are 3 and 4, you can immediately assume the hypotenuse is 5. So like if you see 2 legs that are 8 and 15, you can immediately assume the hypotenuse is 17. Or if you see a hypotenuse that's 25 and a leg that's 7, then you know the other side is 24 without even doing any math. Does that make sense? Okay.
So this will make life easier.
Yes, if you know these. So the other things is the multiples of these also work. So if we did, that's not what I wanted to write. If we did 2 times these numbers, so like 6, 8, and 10, that would also be the Pythagorean triple. Does that make sense? Okay, so 10, 24, and 26, 16, 30, and 34, and 14, 48, and 50.
And 3 times and 4 times?
It also works for 3 times, and don't put 4 times as the last one. It's not that. I'll show you in a sec. So the next one would be what? 9, 12, 15.
15, 36, 90,
39. Then what?
24,
39.
45 and 51?
Oh, wait. God, I wrote the wrong number. I wrote 13 again. My bad.
21,
This one's tricky.
144.
Divided by 2.
Is it 72?
It is.
72. Tyler.
And 75. So this is like the rule. So if we can take these triples and it's 3 times a number, comma 4 times that same number, 5 times that number, then that's a Pythagorean triple. Does that make sense? Okay. So again, here, if it's 5 times a number, 12 times that same number, and 13 times that same number, it's another Pythagorean triple, and so on and so forth.
I'm so confused. Wait, so how do we know? Is it
Because it's 5, 12, and 13, so you can do 5 times the number, 12 times the number, and 13 times the number. Yeah.
Mm-hmm.
okay.
And there's more than just this list. Like, there is a plethora of Pythagorean triples. These are the ones I want you guys to know. These are the biggest ones. Like, the ones you're going to see the most are these 4. And beyond that, beyond these 4, you can do the Pythagorean theorem. Does that make sense? Okay. So let's use a Pythagorean triple. What pattern do we see here? 12 and 15. Yeah, so this 12 is technically 3 times what number? 4, right? And this 15 is technically 3 times 5. So we have 4, 5. What would the other one be?
9.
Yeah, because it would be 3 times 3. Does that make sense? It's a 3, 4, 5 triangle. So that x is 9.
Is there a way we can prove on that? Like, double check ourselves? Can we just do the normal Pythagorean?
You can, but if it's asking you specifically for the Pythagorean triple, I don't want to see that.
And I'm saying, can I do it?
If you want to check yourself, you are welcome to. Okay.
I want to see it.
So then the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, then a triangle is a right triangle. Shocking, I know. So it's saying in this picture, if we have that a squared plus b squared equals c squared, then we can assume that, okay, I have a right angle. What's always going to be our c squared? Okay, which is, yeah, but if I just give you a list like this, how do you know which one is your hypotenuse? It's the longest one. So in this one, it says, is a triangle with the following sides a right triangle? So we want to test it. So, okay, so how would I set this up?
11 squared plus 60 squared equals 61 squared.
Okay. So what's 11 squared? 121. What's 60 squared?
3,600 or 36,000?
And 61 squared is what?
3721.
3721. So are these equal? Yeah. So is this a right triangle? Yes. Okay. The other thing we need to remember is, how do I even check if something's a triangle or not?
I mean,
No, the angles have to add to 180, but these are the sides.
no,
Just,
like,
we did do this.
11 plus 61 has to be greater or something?
Yeah, 11 plus 61 has to be greater than 60.
And then
60 plus 11 has to be greater than 61, right? And then 60 plus 61 has to be greater than 11. Are all those true?
Yeah.
Yes. So really, we first have to decide, is it a triangle? And then we have to decide, is it a right triangle? Does that make sense? I didn't do that first step because I knew that it was a triangle, but we should be doing that because you may have one on your homework like that. Okay. Can I go to the next one? Yeah. Okay. So let's first check this time if this is a triangle. So how would I do that? Is that greater than 16? Yes. So then we want to do is 14 plus 16 greater than 7. And then is 16 plus 7 greater than 14? Okay, so is it a triangle? Yes. Okay, so now let's see if it's a right triangle. So how am I going to set that up?
7 plus 14 squared equals 16 squared.
So what's 7 squared? 49. What's 14 squared?
196.
196. And 16 squared?
256.
256. So on the left side, what am I getting? 245. Is that the same thing as 256?
Nope.
So is this a right triangle?
Nope.
No, not a right triangle. Also, I just reread the directions, and do you see how it says is a triangle with the following side lengths a right triangle? So it actually already told us that it's a triangle. Does that make sense?
Yeah.
But if it just asks, do the 3 sides make a right triangle? Then you have to decide if it makes a triangle and then if it's right. Does that make sense? The difference between those two?
Yeah.
Okay. So we have a little bit more information about that Pythagorean theorem. And this is kind of the last things. So we have what's called, in addition to the Pythagorean theorem, we have the Pythagorean inequality theorems. And so the first one says that if our hypotenuse squared is actually less than our a squared plus b squared, then instead of being a right triangle, right, because when they're equal, it's right, this would be an acute triangle. Does that make sense? Okay. Now, when the hypotenuse is bigger, when it's greater than a squared plus b squared, then this would be a what? Obtuse triangle. And we see that in this picture as well. So in the first one, c squared is smaller than a squared plus b squared, which is why it's tiny there. And then in the last one, it's bigger. Okay? Are we okay there? Okay. So we want to determine if the triangle exists, and then if they do, classify as acute, obtuse, or right. So what do I need to do first? Yeah, I have to see if it's a triangle first. Does that make sense? Because this one says determine if it exists. All right. So let's start there. So we're going to say, okay, is 12 plus 35 greater than 37? Yes. So is 35 plus 37 greater than 12? Yes. And is 37 plus 12 greater than 35? So is this a triangle? So yes, the triangle exists. So that's our first step. And then I want to classify them. So which one's my c squared? 37. So I'm going to do 37 squared. I'm going to kind of put a blank here because I don't know what symbol I'm putting between there. Does that make sense? Okay. And then we're doing a squared, which is 12, and b squared, which is 35. So what is 12 squared? 144. You may need a calculator for this one. What's 35 squared? 1225. Again, we don't know what symbol we're putting here. And then what's 37 squared? I did not hear that. What was it? 369. Okay. So we'll add these together and we should get 1,369. So what are these? Yeah, they're equal. So this is a right triangle. Does that make sense? Okay.
Yes.
Let's do it again. No, not this one. Yeah. Okay, so this one, again, what do I need to establish first? Is it a triangle? Is 5 plus 12 greater than 17? No. So is it a triangle?
No.
No, not a triangle. And if it's not a triangle, can I determine if it's acute, right, or obtuse? Nope. We're done. Next one. Why don't you try this one? Huzzah. They're going to hear that in the video and be like, what?
Claire's gonna bully me. She's gonna be like, why didn't this happen?
Like the same thing we did.
Yeah.
Mm-hmm.
Okay.
Oh, snap. I love that you guys color coded so cute. I had dark versions. I haven't used that colors.
I feel like color coding helps sometimes to like organize your thoughts.
I thought so.
And then sometimes I forget that I'm color coding and then it just goes wild. But we got the nice pens.
I don't think that's very gorgeous.
Pretty.
Sounds so sad.
Yeah, well, I also make it in the video so they can't skip. So I think that's part of the reason why they hate it. Because they can't skip to the content. But I'll cut all of this out. I got new chapstick and it's strawberry flavored and I cannot stand it.
You should get vanilla.
I got like a pack.
Oh.
So I got like vanilla, normal, strawberry, and like pear. And it's in my desk.
I got this chocolate from Walmart. That
It's
tastes like
coconut
caramel
and
macchiato.
pear.
Miss Brown says
It's
she
coconut
wants
and
to
what?
organize your desk for you. We left that one in. Just kidding.
What?
When we had our test, Miss Brown said she wants to organize your desk for you.
Mm-hmm.
Yeah, I know.
It's like, if it's organized, how can do?
I just like, I did clean it a little on Friday, but I know that my desk is a mess, but I know
Like where everything.
I know where everything is,
That's
and
what I
like,
said. It's if it's a mess, I don't know where everything.
and I
is.
hate it when people like, I know that it was messy, and I felt bad for leaving it to her like that, but I just like, I want to know where all my stuff is, and I'm so like, I tend to lose things. That's why I'm always like, put it in the bin. Like, I don't want it. I'm gonna lose it if you hand it to me.
So it's up to.
I don't know. I haven't done it yet. Okay, are we ready?
Yeah.
Okay. So we should have first checked 16 plus 18, is that greater than 26?
Yeah.
Yeah. Okay, so then 18 plus 26, is that greater than 16?
Yeah.
And 16 plus 26, is that greater than 18?
Yeah.
Very good. Okay, so a triangle exists. Okay, so next we want to check to see what it is. So we're going to say, okay, 16 squared plus 18 squared. And again, I don't know what's going here yet, so I'm going to leave it blank for right now. And we'll do 26 squared. So what's 16 squared? 256. What's 18 squared? 324. And what is 26 squared? Okay. So I'm going to get, what, 580 and 676. So what is it? Which one's bigger? 676, which is the hypotenuse. So that means that this is obtuse. And if it was the other way around, it would be acute. Okay? That's it. All right, let me tell you what your homework is. Okay, let me get the pages right. It's page 580 to 581. Numbers 10, 12, 14. Why don't you also write them so that if I mess them up again, you have them correctly? They are. Okay, then check the calendar. I feel like the calendar is pretty consistently right. It's sometimes the posting is not always correct. Are we good? All right. then you guys had the last 15 minutes to work.